Hey guys, welcome to my channel. My name is Mike, and if you're new here, I am doing a rebuild on a Case 1840 skid steer, more like a restoration, I guess. And the goal for this video is to get this engine inspected, tear it down enough to see what kind of condition it's in, to see how far we need to go. If you don't know, the Case 1840 uses a Cummins 4B engine, which is a lot of the reason why it's such a highly desirable skid steer. So let me take you back real quick and see what we've done so far. So this is currently where we're at in the project. There's a lot of other videos getting it to this point. We are sandblasted, painted, and most of the loader and auxiliary hydraulics are installed. So next up is to get this engine that's been sitting here waiting in a condition to where it's ready to go back in. I've been using this parts cart to keep everything organized, and I created a clear shelf to put all the engine parts on. That way we can keep everything organized. Well, I'd like to bore scope the cylinders, so I'm going to start with getting the injector lines off. I've worked on a lot of engines, a few diesel engines, but I have never worked on Cummins 4B. It looks like I'm finding out that it is, interestingly enough, mostly metric. Now I actually remember reading that this machine's all SAE except for the engine. I'm just going to crack all these lines loose. Take the line clamps loose. Okay, we still got the return lines, probably 10 mil, yep. The hole drilled in the side and then down the center. Oop. I lost one, fell down. And that wraps around the back of the engine and goes right there. I'm surprised on how loose that was. That's O-ring connection, so that's why it wasn't very tight. And then these are all those copper washers I was talking about. Okay, I'm gonna put these little caps over the injectors to try to keep anything from getting in them. I just checked the manual. It shows using a special service tool, of course, but from what I can gather, basically wants you to hold the top while you loosen the nut, because I think there's a pin that locates them on the body, so they probably don't want you to strip the pin off. Alright, so I can't hold the two at the same time without the tool, without having this exhaust manifold out of the way. So I'm going to see if I'd be pretty surprised if that just comes off without breaking something. too good to be true. That's in pretty good shape. I'll place all those bolts going back together. Now I should be able to get something on that. Don't know what size I need yet. .15/16 fits pretty good. I'm sure that's probably not what it is, but we do need. Says in the manual you want this all clean around here because when you unscrew them you don't want anything going down in there. So I'm gonna get a blow gun and get that cleaned up. All right, I'm gonna hold the body while I loosen the jam nut. There we go, that worked. I'm gonna grab a pliers and see if I can yank it up out of there. Nope. Well, I'm gonna do some research on that, and we'll come back to that here after a bit. In the meantime, let's pull these valve covers off. I just want to take a look inside. Probably end up setting them back down on there. All right. Looks nice and clean, so that's good. I just kind of wanted to get an idea what this engine looked like, so yeah, they all look basically the same. So I am going to just leave that for now. I did a quick internet check, and to get those injectors out, there's a little sleeve puller. I just ordered one on Amazon that'll be here tomorrow. So I'm not going to worry about that. Right now, I'm going to get some of this other stuff pulled off of this engine. I think it's that way because I took the fan off. Yep. It's rusty on the outside here. Let's see, the belt looks pretty good actually. Water pump feels good. That sounds a little loud to me. All right, it's a couple days later, and I got the little Amazon puller in, and it looks like it just slides over the injector body, and it uses the actual threads on the top of the injector where the line connects to pull up the injector. Let's see here. shims. And someone else commented it needed to be a little bit longer. I found some of these shims I think will work here. It's still surprisingly difficult to get out. Tell I haven't done this before. There it comes. There's dirt and all kinds of stuff on there. Go. So number one injector's kind of behind this engine hook. I got to strip this stuff off the engine anyway, so I'm just going to get this stuff out of the way to make it easier. That gives me a much better access to this injector. There's no reason to fight it when all that has to come off anyway. Kind of look at. Okay, so the only way we're going to be able to do a compression test with this thing is to throw the bell housing back on and the starter. I got this new bell housing because the other one was cracked and welded and I didn't really like that. So let's see if this should fit. All right. Like something like that, I'd say. These don't need to come off. is all just temporary, just to do the compression test. Okay, now the starter, I taped the bolts around it here. Now the other bell housing only used only had a 2-bolt flange starter. I don't know if that's correct. I will check. All right, getting ready to do the first compression test, and I got this adapter that screws into the injector hole. I guess I need to get some Vaseline to hold that in place. Okay. All right. Gauge, snap it on. I got a pair of jumper cables all the way from my truck parked back there. It's almost not long enough. Okay, now we just have to jumper power to the starter solenoid wire. Ooh, that's not good. Okay. I really thought that would work good enough. All right, let's try that. I got 200 amp jump starter hooked up to it, as well as the truck. See what it does. Uh, 340 maybe. Again, about 340. I think consistency here is better than what the actual number is going to be. Okay, let's do number 2. Over 350. So it looks like 360 to me. Number 3. And we got 370 on that one. I'm not sure if it's just cranking over faster or not. We'll check one of the others again. Okay, cylinder number 4. About 340. Okay, here's number 1 again, just to double check my number. And see, that time I got 360. Okay, let's go for number 4 now that we've waited on the battery charger. Oh yeah, 350, 370. So again, that has more to do with the battery state of health than it does anything. So just to recap, 360, 370, 360, 370. I think I could get both of those up even more. I think I'd get them all up probably to 400 if I had a better cranking speed. But I'm gonna compare that to spec. I think it's, I don't think it's alarming. I think it would be alarming, more alarming if one of them was significantly lower than the other, but it's not. So compression-wise, I think this thing is pretty healthy. I got the bell housing and flywheel back off. I need to keep stripping this engine down. Now let's see. This is the loader pump drive coupler. They strip out commonly. This fan bearing, it was kind of loud, so it needs to get replaced or fixed. I'm going to take this lower plug out. At least I can get, oh wait, that's tight. Get rid of this. Should have bought a metric set of these too, but I didn't. Now I'm paying for it. These are Astro, and I like them so far. I just don't do a whole lot of metric because I'm mostly working on old American stuff. Plus I'm working on my cars. There's some coolant on the bottom of the, right there. Okay, water pump. All right, hop up on there. Turn the propane on. You know how to start it? Yep, and you gotta pump the gas. There you go. All right, hang on.
Now what do I do?
Put it in reverse. Give it some gas. There you go. All right, stop. All right, lift up the forks. Put it in neutral. All right, angle it back. Stop that. There you go. going. Okay. All right, now I don't want you to run into the engine. Raise the forks. Let me get on the other side so I can. More. Raise them more. All right, now that's to go forward. Oh, hold on, slow. Slow, a little bit. Okay, let off. Hit the brake so you know where it is. There you go. All right, go ahead, forward. I'll turn towards it to get this fork centered over the engine. So turn, get it over here. All right, stop. Okay, raise up on the forks. Put it in neutral first. There you go, raise up on the forks. Stop. Okay, come on up. No, no, no. The fork up. Don't move the fork lift. There you go. Okay. Come on up. All right, stop. Put the parking brake on. All right, ring her up. Stop. All right, turn it off for now. Turn the key all the way off. There you go. Slowly lower the engine down. Slowly, slowly, slowly. There you go. There you go. All right, hold on. Too much. Too much. Okay, back it up. Slowly. Okay, stop. Stop. Put the forks down. Wrong way. Down. All the way down. Put it in neutral. It's rolling on you. There you go. Oh, now you put it forward. Put it in neutral. That's forward. There you go. I'm sorry. All the way down. Lean the forks forward. Other lever. Lean the forks forward. Push. No, wrong way. Why don't you give me those boards so I can pop this up? Right here, bud. Put the big one on the bottom first. I'll get that one. You're gonna need that one too. I know. It's all right, there's still room. Oh, it's tight. Okay, go ahead and take it loose. Wrong way.
Any fluids or anything?
Shouldn't be.
If there were, what's the possibility of it?
Yeah, it won't hurt you even if there is.
Oh yeah, it's all Oh. No way.
Don't lose the washers, please.
Okay, got both washers.
Alright, so you take the wool loose down, or the line loose down here then with this. Take it
Where
loose,
do you want me to put this?
set them up there.
Where? Like right
Yep. Now take this line loose right here. They don't block the camera. Here, you're going to use this size. That's the fuel pump. Well, yeah, the one that transfers it from the tank to the injector pump.
That looks surprisingly small.
You're going the wrong way. There you go. There you go. Now you might be able to move it. There you go. Let me do it.
I got it.
You got it? Okay, you can do it by hand now. Okay, now you're going to take that bolt you'd set over there and put it through there and set that on our parts shelf. Get that big wrench, take those fuel filters off. Oh yeah? Well, first you need to open up the pliers to where it's more manageable for your hands. It's still not manageable for your hands. Slide the pliers where it's manageable for your hands. That's why it's called a channel lock. Adjusts.
But now it's too big.
Now it's too big. So now what do you need to do then?
It isn't now.
That's probably a little bit too wide on the handle, so you need to go somewhere in between. I know that thing's kind of hard for you to handle because it's so big. There you go. That's better. Oh, you got a hold of my dipstick tube. All right, that's the way you're going to go. You're going to pull it towards you to unscrew it. Clamp it and pull it towards you. There you go. Oh, sorry, I was completely wrong. That tightens it. I keep getting my things backwards because they're upside down. No, now you're against this filter, so you need to back your wrench off. There you go. And normally you would turn your wrench around, but that's okay. Keep going. Oh.
Sorry. Oh, there's a little bit of fuel.
Okay.
Is this a fuel or oil?
Fuel.
Okay.
All right, now you can do it by hand. Now it's going to be heavy, so don't let it fall and slop down in that bucket. You got to hold the bottom of it. You want me to do it?
I think the fuel is getting through the glass.
That could be. You have to go wash your hands after this. Okay, oh, there you go. Good job. Good job. I'll turn it the other way. Now go set it on that. There's a oil bucket over there, down by the air compressor.
Why is there two fuel filters?
That's the primary and a secondary.
it's primary?
I'm not sure.
You know, that doesn't really look like fuel.
It is.
Why is it pink?
Because it's off-road fuel. I'll explain that later. Put that over there.
I know now. You told me about that a while ago.
You got it loose. Hey, nope, put both of those on this line so I know where they went. All right, good. Now go set it on the other side.
Just where the other one is?
Yep. It is a little loud.
How loud?
There we go. Let me have the bolt. Get it on there first. You can let go of the trigger. Get it all the way on. You want to let go of the trigger sooner. There you go. Good job. But go ahead and put that down. All right. That came off there easy. It was fun. Okay, sit these on the ground over there and go find a bag to put them in. Just set them right there and go find a bag to put them in. Okay, I'm kind of curious to take a look at this because of the killer dowel pin issue to see if this thing has been, well, right there's the pin that can come out, but it doesn't look like it has ever moved. So what can happen is that pin is just to align this back housing, and over time, if it works its way out, it falls onto this gear and then causes a bunch of problems. Gets caught in the gear, damages the gear and or case. All right, I think I can take the head off now. I'm not gonna put it on top dead center yet. If I pull the head off, it'll be easier, I believe. Andrew, I'm gonna hand these valve caps covers to you, and you're gonna set them on the parts.
Don't lose the bolt, okay?
That looks pretty clean. It's good. Now we can take the rocker arm assemblies off. Four. Okay, down to the head bolts. Let's see if it'll pop loose here. Scared.
Yeah, it's just gonna all of a sudden like
There it is.
I thought it was down.
As far as I know, it hadn't been off in its entire life, so I don't know how heavy that is. I could probably lift it.
Like the forklift?
Yeah, I'm lazy. I don't want to get all that stuff out. I'll put it up on the bench. Oh yeah. Oh yeah.
We're to the cylinder.
Not too bad. Okay guys, you're seeing it as I am. I'm seeing crosshatch on the wall still. All right, there's the cylinder head. I'm going to put part of the front pulley bushing back on so I can get this thing at top dead center. I don't have the fancy rotating tool that they call out in the repair manual. Yep, it is there. I wonder if that A stands for. So it looks to be correct. See if I can. So the A on the A to that, I need to check if that's probably correct. And then we got a down below. I get a 00 with a 10 on the bottom tooth. So here and there. All right, got TDC lined up on the front. I was able to push this plunger in and engage the cam gear. So then I was doing some reading, and this locks the injection pump when you loosen it and get it off the shoulder. I don't know if I really need to do that, but I'm going to. I plan on probably sending this out just to have it tested. I guess that's not the right. Okay. So now I should be able to take all these bolts out and get this pump off. I'll go ahead and take this gear off, and I did check it. The alignment on this one with the cab pump to the A is correct. Depending on what pump you have, it may be aligned to different things. I don't know if that's tapered and needs pulled off, but put a little pressure on it. If it doesn't come off, then I'll get a puller. Yep. Not too tight. Yep, it's tapered with a key. That's easy enough. Okay, the tappet cover. This is pretty dry rotted. Doesn't appear to be leaking though. Nice and clean. Get the fuel pump off. I think we're ready to flip this guy over. Sweet. It's glued on. Nice. Not too bad. It's here. A little piece of something. But pretty clean overall. This engine really does look good inside. Get the oil pickup off. Nice. Oop, that one doesn't look so nice. Ooh, oh, okay. That scared me for a second. The shell stuck in. Okay, that's a lot better. A lot better. All right, let's get the rest of these out. Well, unfortunately, I forgot to turn my mic on, so lost all the audio, so I'm going to have to voice over the next few clips. I'm trying to think here how I'm going to get the crank out. This is that plate for the rear main seal has to come off before the crank will come out. But I think if I take these back bolts loose, separate the plate from the block, I can push it back enough and then take the plate and the crankshaft out all at one time. Got all the bolts out of the plate, and I'm just going to use a hammer to try to tap it loose from the block. The prior person who worked on this used a lot of form and place gasket maker along with the actual paper gaskets, and most of these parts are stuck really good. So I keep tapping here, but I end up having to use a pry bar to force it off the back, but I eventually get it with no problem. In addition to the rear crank seal plate that needs to come off, the front timing cover has this back housing that is behind the camshaft gear. It also has to come off to clear the crankshaft in there. There's 3 bolts that hold the camshaft retainer, so I'm taking those bolts loose, and then I can slowly slide the camshaft out the front. The lifters or tappets are still in the block at this point, but since the block is upside down, they aren't resting against the lobes of the camshaft. With the camshaft out of the way, now we can take the tappets out. I'm going to take them out one at a time and give them a good look over. Here you can see the one I pulled out. I believe it was cylinder 1. It's got some pretty significant pitting to it, so that's pretty concerning. I'll give you guys a little bit better view of that cam and tappet damage later on in the video, but for now I need to get this oil pump pulled out so we can continue to disassemble this thing. We got the rear of the front cover that needs to come off, so we're going to take a few 10mm bolts loose and get that off. With everything out of the way, we can finally get this crankshaft lifted out of the block. This crank is pretty heavy being a diesel, but I am able to get it out of here, and then I'm going to set it over on my welding table, and I'll give you a good look to see what the block looks like with everything stripped out of it. The mains don't look so bad, and the pistons are still down in there. Okay, I got the engine turned back around, and I'm taking a look to see how much ridge there is and the carbon I need to remove to get the pistons out. Fortunately, there's really not any kind of ridge, but there is quite a bit of carbon. So off camera, I took a real fine Scotch-Brite pad and some solvent and cleaned all of the carbon off so I could get the pistons out. And then in the next following clips, I'm going to take each piston out one at a time, and then I think my audio comes back so I don't have to do any more voiceover. All right, guys, got the block all tore down, cleaned up, and I'm just going over some of the parts that I took out. These are the cam tappets. They go up and down with the lobe of the cam. You can see this one's got some pretty significant damage on it. There's a couple other ones with some minor areas. This is definitely a problem. So if anything, tearing this motor apart other than resealing it, finding that was a good catch. And then the camshaft has a similar small mark on it. Let's see if I can find it here. Where it's got some fret, I don't know if it's called fretting, but it's damaged, so not real happy about that because I would prefer not to put an aftermarket cam in it, but I might be forced to. Okay, I'm going to check the ring gap. I took the top compression ring off number 1 cylinder, put the piston face down to square the ring up in the bore, and this just gives me an idea how much wear there is. So 0.65 millimeters goes in. 0.7 goes in, 0.75, and 0.80 millimeters, so 32 thousandths is tight. Goes in, but it's snug. All right, continuing on with piston ring inspection. I'm going to measure the clearance between the ring land of the piston and the ring itself. I'm doing the number 1 or number 2 compression ring. Let's try at 0.09. This was, my bad. Let's see. That was a 3 thousandths, which is 0.08, and this is a 4 thousandths, which is 0.10. And that's kind of snug. I'll try a 5 thousandths. So that will not go in. So 0.10 is the actual measurement, which is 4 thousandths. So the spec on that is 0.15, so it is within the spec. And then on our ring gap, it was 0.80. That was snug going in. Service limit, that's what these are actually, 0.806. So according to that, it's close, but still within. All right, guys, so we're going to check the cylinder bore, and I actually have some formal education in automotive machine work. I've bored cylinders, so I'm relatively experienced in this. I got a set of nice micrometers and a dial bore gauge, and I just checked this micrometer with a 4-inch standard, and it is right on the money. So what we're going to do is set this mic to the service limit, which is 4 inches 20 thousandths. So let's see if you can see we're lined up on the 20. That's and then there's hash marks on the barrel. Each one's 25. So if I would rotate this and it goes to 0, that's because it aligns to the dash on the barrel. So now that's 4.025, and then that's 30, and you just keep counting and adding them. But we're not. We're going to be at 4.020. Going to lock that down. So then what you do is you take a dial bore gauge. I've had this one for years. It's a Fowler. It's fairly inexpensive. So then you're going to set the dial bore gauge to the mic. And let's see. So we need these little extensions, and then we're actually going to need some of these spacers. I got copper jaws in here, so I'm going to clamp this micrometer in here. Okay, so let's see if you can see the mic. So you're going to set this. Yep, so I got to take a spacer out. There's only so much travel on this little button, so if you get it too much spacer, the travel bottoms out. So it's a very delicate operation. So you're going to, this thing doesn't actually read anything other than how much bigger or smaller than your mic. So I'm going to scoot this back, this camera. Hopefully you guys can kind of see what I'm doing here. Try to explain it as I go. So we're going to center it on the mic over here on this side, and then we're going to find the smallest reading and zero it on the gauge. And that will be set to the mic. It's a little finicky. Lock that, and then I'll double check it. It's off about a thousandth. So basically you're just transferring the measurement to the gauge. And you want to find the smallest reading, and it's barely off. All right, so that's set to 0. I'm going to go over to the cylinder block here. So we want it to read less than 0, because if it's worn past the service limit, it's going to read bigger than 0. So that way it's smaller going down. So we don't want to read on this side of 0, we want to read on the other side of 0. So we're reading about 3.5 thousandths smaller than the service limit. So that means we're good there. Check it the other direction. So that's basically 3 thousandths. So we're at the top, which is usually where the most of the wear. That was 0.5 thousandths more going this direction, but you got to throw the crank, so it's usually going to wear more here. So let's check the bottom. Three again. Yeah, that was like 4. So I'll double check these other ones real quick. Actually, I'm going to do it on this direction is going to be the most worn. Hopefully you guys can see this. Okay, cylinder 2. Again, 3 thousandths under the service limit. Cylinder 3 is 3 thousandths under the service limit. And 3.5. So this block, so the service limit was 4.020 and roughly 3 off of that. So we're measuring 4.017, which means there's absolutely nothing wrong with this block. Now you can check taper and all of that, but it's based on how good a condition this block is in, it's probably a waste of time. So I guess I'll show you the check taper. So that's 3 thousandths less, and then at the bottom it's basically 3 thousandths less. So it has no taper. I guess you'd call it out around by 0.5 thousandths because of the little bit more wear in the direction of the throw of the crank. Okay, now I'm going to take some measurements on the crankshaft. The bearings look great, but I'm just going to do this to show you guys how to do it. This is a 2 to 3 inch mic. We're going to check a rod bearing. And you're going to put it around the journal, and you're just going to go up and down past the largest area. Keep turning it in until you feel just a hair bit of drag. You don't want to crank it down. Okay, let me read this. Okay, this is so 2 inches. Then on the barrel, we're lined up with the 7, so 2.7. And we're not quite to the next hash, so we're under 2.725, so we're 2.715, 16, 17. 2.717, so let's compare that to spec. Okay, I looked up the spec and converted to inches. We measured 2.717. Max service limit, which would be worn smaller, 2.715. So we're good there. Let's measure the main journal. Before we do the mains, I just want to show you another way. You could set your micrometer to the service limit, 2.715. So we're on the 715. And just do like a go, no-go gauge. It should not be able to go past. And it doesn't. And you can do that to every journal. So all the rod bearing journals are good. We're going to do that same go, no-go in the mains. Converted that spec to 3.266. So I got a 3 to 4 mic. We're going to run the dial on the barrel till 3. So that's 3.20066. So we're going to need 3.225. Go around again, 3.250. I think it was 66, right? So 50 plus 16. There. 3.266. Good. Good. And just for the heck of it, this back journal was worn the worst. So I'm going to see what it actually measures. Let's try that. 6, 7, see if that goes past. No. 6, 8. Yep, that does. Let's go in between 6, 7.5. Six, 7. So just a hair more. It's about 6, 7.5, best I can tell. Yeah. Unfortunately, I'm going to have to end the video here. Got a lot of cleaning up to do, a lot of decisions to be made as far as what kind of parts I'm going to put back in this engine. Mostly concerned about the cam lobe and the lifter tappets because I'm afraid to put aftermarket parts in this engine because I've been burned in the past. And I did reach out to Cummins. They do have the part. It's $800, which I don't want to spend, but also they didn't have any in stock. And then they told me that the stock they did have was in China. So it made me suspicious of it's just an actual rebranded aftermarket part. So I don't think it's a genuine, Cummins part. It's probably got their name on it, but I don't know that it's any different than you know, $150 one you can buy off eBay. Maybe it is, maybe it isn't. And other than just cleaning everything up, doing some more measurements, I just got some decisions of what kind of bearings I'm going to put in it. Not doing pistons or any boring on the block, obviously, based on the measurements. But I'm going to do a second video on this, going over the head. I need to get a valve spring compressor. The ones I have won't work on this head. So I need to locate one of those, and then I'll kind of go through the head and what I'm all going to do to the head on this next video. So anyway, stay tuned, more to come. Appreciate you guys watching. Give me a thumbs up. Thanks.